So let's get something out of the way. The Big Bang Theory is not just an idea. It's not a quirky guess someone threw out at a science conference to kill time between coffee breaks. It's a scientific model built on a skyscraper of evidence, all of which can be independently verified by anyone with a telescope, some math skills, and a disregard for getting a tan. And yet, some people still insist it's fake. Why? Because it's easier to shout fake news than it is to read a physics paper. Let's kick things off with the backbone of the Big Bang Theory, the observed expansion of the universe. Back in 1929, Edwin Hubble, yes, the guy NASA named the telescope after, and no, not because he paid for it, discovered that galaxies are redshifted. No, they didn't get embarrassed. Redshift means their light is stretched, a sign they're moving away from us. But here's the kicker. The farther away they are, the faster they're speeding off, like exes after a breakup. This isn't just a random trend, it's a precise, measurable, linear relationship between distance and velocity. And what's the best explanation? The universe is expanding, space itself is stretching like cosmic taffy, just as predicted by Einstein's general relativity. Okay, cool, the universe is expanding. Big deal, right? But wait, if it's expanding now, doesn't that mean it used to be smaller and smaller until it was everything squished into one incomprehensibly dense point? That's exactly the idea behind the Big Bang. And unlike your roommate's theory about cats being government spies, this one actually makes predictions that match observations. Enter our second line of evidence, the cosmic microwave background radiation, or CMB for short. In the 1960s, two guys, Penzias and Wilson, were trying to fine-tune a radio antenna and kept hearing this annoying hiss from every direction. They thought it was pigeon poop. Turns out, it was the literal afterglow of the universe's birth. This CMB is a uniform background of microwave radiation with a temperature of about 2.726 Kelvin. It's everywhere. And I mean everywhere. You can pick it up with a microwave receiver in your backyard. It's like the universe's baby photo, and it's just as awkward and revealing. So where did these microwaves come from? Well, shortly after the Big Bang, the universe was a hot, dense soup of particles, too hot for atoms to form. It was an opaque fog of protons, neutrons, electrons, and photons all bouncing off each other. But about 380,000 years after the bang, things cooled down enough for electrons to combine with protons and form neutral atoms. This event, known as recombination, suddenly made the universe transparent. Photons, particles of light that had been trapped in this fog, were now free to travel through space. And they've been traveling ever since. Over billions of years, as the universe expanded, these photons stretched into longer wavelengths, cooling down into microwaves. That's what we detect today as the CMB, the stretched out, cooled down light from the universe's first visible moment. But it gets better. Satellites like COBE and WMAP came along and measured tiny temperature fluctuations in the CMB. These anisotropies are like little ripples, primordial density variations that eventually formed galaxies, stars, and Instagram influencers. And those ripples? Their distribution, size, and temperature patterns match exactly what the Big Bang model predicts. You don't get that kind of accuracy from making stuff up. If this were a guess, it would be the most accurate guess in history. Better than your grandma predicting rain from her knee pain. Still not sold? Let's talk about chemistry, cosmic chemistry. Big Bang nucleosynthesis, BBN, refers to the formation of light elements in the first few minutes after the Big Bang. I'm talking about hydrogen, helium, deuterium, helium-3, and lithium-7. The Big Bang Theory predicts the specific ratios of these elements. So we looked. And guess what? The observed abundances match the predictions. I mean, what are the odds? This isn't horoscope level, you might feel emotional today vagueness. It's hard numbers. About 75% hydrogen, 25% helium, and trace amounts of the others. Measured, verified, confirmed, multiple times. Here's the cherry on top. These three lines of evidence, the expanding universe, the CMB, and nucleosynthesis, don't just stand alone. They converge, like detectives from different precincts showing up with matching clues to the same mystery. And when independent evidence lines up this perfectly, it's not coincidence. It's science singing in three-part harmony. So let's recap. You've got galaxies running away like there's a cosmic fire drill. You've got the leftover glow of the universe's wild birth party. And you've got chemical fingerprints written into the very atoms of space. And all of it points to one thing. The universe began in a hot, dense state and has been expanding ever since. Skeptics might argue, well, there are still questions. And yeah, there are. That's science. If we had all the answers, physicists would be out of a job and we'd have to stop making YouTube videos. But unanswered questions don't invalidate mountains of evidence. They just give us new mountains to climb. So next time someone tells you the Big Bang is fake, just smile and offer them a telescope, a physics textbook, and a cookie. Because the universe isn't a scam. It's the most epic origin story we've got. And if you enjoyed this cosmic roller coaster, don't forget to like, subscribe, and comment with your favorite Big Bang fact or your weirdest space theory. We read them all. Some even make it into our next episode. Until then, keep questioning everything except gravity. That one's pretty solid.